This is day 3 of Advent of Code 2024 in Go, and this challenge is called Mull It Over. Our computers are having issues, so I have no idea if we have any chief historians in stock. You're welcome to check the warehouse though, says the mildly flustered shopkeeper at the North Pole Toboggan rental shop. The historians head out to take a look. The shopkeeper turns to you. Any chance you can see why our computers are having issues again? The computers appear to be trying to run a program, but its memory, your puzzle input, is corrupted. All of the instructions have been jumbled up. It does seem like the goal of the program is to just multiply some numbers. It does that with instructions like mul xy, where x and y are each 1 to 3 digit numbers. So for instance, mul 44, 46, which multiplied together is 2024, and also 1, 2, 3, 4 would multiply 1, 2, 3, 4. However, because the program's memory has been corrupted, there are also many invalid characters that should be ignored. Even if they look like part of a mul instruction, sequences like mul 4 asterisk, mul 6 9 exclamation, or question mark 12 34, or mul space, and so on, do nothing. So for example, considering the following section of corrupted memory, if we have all of this, only the 4 highlighted sections are real mul instructions. Adding up the result of each instruction produces 161, so 2 times 4 plus 5 times 5, and so on. Okay, so let's take a look at this input first. Okay, so this, it's hard to tell if it's one whole thing or if it's multiple, one single line or just multiple lines. So I want to take a look at this first. So let's do format.print. Let's do lines 0, see if it is a list. So print out the one which starts with who. Actually, okay, I don't actually need to split it for this one. So I was thinking this would be a good regex challenge to do. So you just write the format of mul parentheses digit comma digit closing parentheses. So you could do that regex and it'll just retrieve them all. Then you would have to then have to convert the numbers to make sure that it's what was the instruction? Was it 3 digits long? 1 to 3 digit numbers. What if I would include negative numbers? Actually, well, we might as well get started with this. So I'll remove this. We will import regexp like that. I don't need strings anymore. Whoop. Then we can do the regex is equal to regexp and must compile, and this would be mul parentheses, so backslash parentheses, and then we need to capture the digit, so parentheses slash d, and because we want it to either be 1 to 3 digits, curly brace, so 1 to 3, so mul opening parentheses, the digit we want to capture, then this would be comma, then this capture again, and then the closing parentheses. So we've got our regex. I hope that is how that would work. And let's do matches equals re.find all string submatch. This would be input. And what's int for? Can we look at the definition for it? What's in n? Okay, so if n is less than 0, n is equal to the length. Okay, so I assume that's just how much of the string we do. So make this -1. Actually, I think we're using the wrong function. That was a string one, wasn't it? Because it's currently saying we need a, there we go, string submatch. It was saying byte array, but we're obviously using a string. So matches, out of curiosity, let's just print what matches is. Alright, forgot that. That looks like it's working. Okay, cool. That looks like it's working perfectly. Didn't think it would actually work straight away like that. Guess my regex isn't too bad then. Okay, so we've got all of our matches. Let's iterate over the match. This would be range matches, and we'll do num1 is equal to match, and it returns a list, but the first one is the whole string of matches, and then it's the numbers. So that'll be match 1. Oh yeah, we need to string convert. So string convert toy match 1, and then we do the exact same thing with match 2. And what error is it happening here? Assignment mismatch. 1 variable must convert returns. Oh, okay, what is it returning? Oh yeah, error. So skip the errors. It's got num1, num2. Then it'll be output plus equals num1 times num2, and then that should be it. Okay, let's see if that number is correct. And that number was correct. So, on to part 2. As you scan through the corrupted memory, you notice that some of the conditional statements are also still intact. If you handle some of the uncorrupted conditional statements in the program, you might be able to get an even more accurate result. There are 2 new instructions you'll need to handle. The do instruction enables future mull instructions, and the don't instruction disables future mull instructions. Only the most recent do or don't instruction applies. At the beginning of the program, mull instructions are enabled. Okay, interesting. So for example, we would do this, so it initializes as do, so do this. Then would be don't, so skip, 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 do this one. So this corrupted memory is similar to the example from before, but this time the mull, these 2 mulls are disabled because there is a don't instruction before them. The other mull instruction function, normally including the one at the end, then gets enabled. Okay, interesting. So let's get started on part 2. So I guess straight away we can copy all of this into here, and what we can do, I think, is just add extra conditions to the regex for the do and don't. So we'll do do slash parentheses slash parentheses, or don't and slash parentheses slash parentheses. So let's print out all of this just to see if that is working. So we can see, are there any do's or don'ts in here? Okay, we've got this don't. Okay, so we've got that. I want to try in here, remove that print. If match 0 equals don't, format of print don't. Okay, cool, that's working. Now we'll try it with do, just so we can double check it's working as expected. I printed out don't, but it's working on do, so that seems to be working. So what we do is do, start that off as true. If match equals do equals true. Else if match equals don't, do then continue. If it equals don't, then do equals false continue. Then we can do an else if not do continue. So I think that should be all that needs to be done. So let's run it. We now have this number, so we'll go submit it, and we got the right answer. So that is day 3 of Advent of Code 2024 done and go. If you like this video, make sure to like and subscribe.